Hello, my name is Dr. Armando Ponzi from Rome, and I'd like to share with you the part 2 of socket shield and image guided planning, single step implantoprosthetic approach. But let me thank first Dental XP and Dr. Salamas for the great opportunity of experience sharing, and about socket shield all doctors involved in the project for the insight on the field. We know from their case report that socket shield allows a preservation of buccal bone wall, soft tissue maturation, a reliable healing, and simplified procedure. In the clinical picture of the case presented, we see here the initial case, the socket shield and implant in place, the accuracy needed on guided implant in order to position an immediate customized abutment, and the provisional. In order to do a single-step surgical approach, it's mandatory to have a digital image planning, and this is the workflow. The digital planning, the surgical stand planning, the Atlantis abutment, the lab planning, the surgical session, and a evaluation session. In the digital planning, we start as usual with a clinical analysis. We then have some photos of the case. An X-ray CBCT was taken for the initial study and for it to be included in the digital planning. Impressions can be taken in two ways: having a stone model scanned with extraoral scanner or using an intraoral color scanner. We see here the resulting image of superior scanning, and this procedure allows us full details of gingival margin in order to build the initial provisional. We see now the antagonist, and again we can turn it around the space and check for all details. And the occlusion that is taken directly from the patient mouth, and probably it is more reliable than the traditional one. File was sent to the lab for virtual provisional, and you see here the lab work about the virtual provisional. And then we had a digital planning. We superimposed the virtual provisional on the model plastic. We then choose the implant brand, the diameter, the length, and a standard abutment. We include all these items into the digital planning, and we see here the bone in transparency, the two roots, adjacent root and implant, standard abutment, and provisional, correctly positioned. But we can also see that in a cross-section to check if the implant is correctly oriented and included in the bone envelope, and see the relation between the standard abutment and provisional, and we can see that 360 degrees in the space. And we see here the relation between the root we have to extract and the implant and standard abutment. All items were removed, and we have here the implant and the root we need to socket shield. We can see that around the space and see relation between the root and the implant itself. Or we can do something more. We can do a virtual socket shield, and you see we remove all hard tissue in order not to have any conflict between implant and the socket shield root left. And we can see that into three-dimensionally into the space and bring it back into the project and see relation between socket shield, bone, standard abutment and implant. Also in a cross-section situation, and we can remove and add the socket shield for more valuations.
The digital planning allows new data manipulation, creating original images and new insight that we'll see in the next slides. In here, relation and distance between implant and virtual crown can be easily valued and measured. The customized anticipated abutment plays an important role in the single-step planning surgery, and we see here how the standard abutment has a very poor adaptation over the provisional. The customized abutment instead has a very anatomical profile because it's digitally studied, and we see how it fits well over the provisional. We can appreciate now a superimposition between the two and see how they differ in the 3D space and in relation to the provisional. In this lateral view, we see the implant, the standard abutment, and its relation to the provisional and to the Atlantis one. In the second one, we see the relation between the implant and the customized abutment over the first provisional and Atlantis one, and we see how the internal fit is absolutely perfect. Once the implant has been correctly positioned into the space and into the bone, the surgical guide is going to be designed over the very first impression that we see here in pink, superimposed over the CBCT. Once the surgical stand planning has been completed, we email the file to Simplant for stand production. We see here main features of surgical stand. We must have accurate data and an accurate digital planning and a production from file. We used in this case a safe type one with drilling and implant control of depth and long axis. Email implant position was sent to Atlantis for anticipated customized abutment project. The abutment design was positively evaluated for production, and core is the file of 3D abutment design. We got to know that the abutment is designed on the initial lab provisional, as we can see in the picture on the side. The design project contains the information of correct distance from provisional walls. No information of internal geometry of the provisional is given in this phase. The Atlantis abutment core file was included in the planning, and it was then sent to lab for final definition of the prosthetic margin and provisional production. And we see here the abutment that is included in the patient impression and the relation with implant, gingival margin, and we see now included in the bone and see the relation between bone and socket shield in different orientation. And now let's go through the digital lab work. The first provisional shoulder region
will be modified in order to fit into Atlantis abutment. This picture shows how the provisional margin fits into the custom abutment, and we see their relation with teeth and the marginal gingiva. In detail, we see the provisional design planning, and in particular the different provisional profile. On the left image, the lab virtual margin adaptation profile, and the right image, the Atlantis proposal, and you see how the laboratory design is much more anatomical. This very last provisional file was sent back by the lab and included in the planning, as we see here. And in particular, we see the implant, the abutment, and provisional in different angulation and within the impression. In this surgical session, we ordered the implant and we decided for an ankylos. And the reason is that it is a submerged implant with a switching platform and a more stable connection. And these three main features are the one that we were looking for a stable connection. And it has an accurate guided instrument sequence on guided implantology called expertise. The abutment Atlantis and the provisional from the lab that were sent to my office, and I was able to reassemble them. And please do note the accuracy and the fit level of the two planned and produced digitally. The surgical stand was checked for proper fit directly on the patient mouth. The stand we used was a tooth-supported one, and that is the most secure and precise stand. Then give an appointment to the patient for the surgical session. In the surgical session, once the socket shield has been completed, the drilling phase should be accurate enough. If surgical stand project and production are accurate enough, the end result can allow the insertion of implant and immediate custom abutment and provisional planned and produced in advance. According to me, some skills are required, and slow drill phase and manual control may improve the accurate 3D implantation. These three images shows the high level of accuracy correlation between the virtual plan lateral pictures and the actual one, the X-ray on the middle. The picture shows the healing phase at 24 hours control. Please note how we smooth out the occlusal crown area, as you see in the circle, to protect implant healing phase from occlusal force. The evaluation method used is called superimposition, and you see in this movie the algorithm and the way it works. Plaster model was superimposed over the CBCT, and the two upper image shows on left the CBCT image and on the right the plaster model. We define 3 points in common on the two images to have the lower one superimposed. We then have a very precise control in several areas to check the accuracy of the superimposition fitting. There are two revaluation methods, a prosthetic revaluation and a CBCT one. The second method will be shown on a 3-month basis. But let's see now the prosthetic revaluation, and this image shows the implant and the very first clinical impression. We then took a second final impression
on the actual provisional, and we see the relation between the planned abutment and the planned virtual provisional. And you see that the space is basically well occupied by the virtual work over the actual one. And the movie shows the type of accuracy on the 3D space. We see the vestibular area in pink, the final impression, and in gray, the virtual one. And you see there is good accuracy on vestibular area and much less on occlusal area, and that is due to the fact that we smoothed out the occlusal surface, and that difference is very well seen on the picture. And we see now a photo textured on the 3D of the patient. And now, in the prosthetic revaluation, let's see a more technical image. We see in the white line the projected provisional and abutment, and in the red line the actual provisional and the implant. And we see that there is quite a nice accuracy between the vestibular and palatal lines of the two provisional, planned and actual one. And we see on the first image how there is a discrepancy on the occlusal surface between the two lines, and that is due to the fact that we smooth out the occlusal surface as shown on the picture. What's important to point out on these images is that we can gather some information about the level of the abutment in relation to bone and gingival margin. The digital way is a new concept based on the use of data. And according to me, more knowledge is required about the healing phase and possible role of custom abutment capability of hard and soft tissue guidance. The custom abutment 1A1T allows a physiologic configuration of gingival profile, reduced or no need to work on later conditioning. And on the initial question, single-step procedure, can this be a new approach? We see here the clinical challenge, and that is acquiring accurate clinical data and digital manipulation, a provision of healing tissue pattern, a control of workflow planning, and it's mandatory to me the digital items production and an accurate surgical execution in order to mount different items in range. But then we got the clinical opportunities, and that is a new way of using knowledge. Data are the key for new processing and possibility of sharing data in a reproducibility way, a possible revaluation of pre and post surgical data, and a one-time healing on the basis of 5 main pillars: socket shield, a 1A1T, a switching platform implant, a customized abutment, and a most taper connection. These 5 main pillars can all be done in a single-step procedures using a planning approach. And my gratitude to Stefano, CheoMediVirtual.com, for support on surgical and digital lab planning. Stefano produced all images and digital film I could share with you. Thank you, Stefano, and thank you to you all for the kind attention.